Welcome back. In this mini lecture, we are going to introduce the topic of percent yield. In the previous video, we discussed this idea of a limiting reactant, and we motivated the concept using a simple analogy involving construction of cheese sandwiches. So as we saw in the previous lecture, we had a scenario here where we had 28 slices of bread and only 11 slices of cheese. And in this scenario, that 11 slices of cheese limited the number of sandwiches that we were able to make to 11. Okay? And so then we classified this cheese as the limiting reactant, the 6 slices of bread as the excess bread that's left over, making bread the excess reactant, and the theoretical yield of sandwiches in this case is 11. Okay, now let's suppose you're actually making these cheese sandwiches. And you remember there's no guarantees that every one of those slices of cheese is going to end up on a sandwich that you can eat. So for example, let's suppose that while you're making those cheese sandwiches, you simply drop a slice of cheese, right? In that case, that initial number of 11 slices of cheese will now have been dropped down to effectively 10, right? Because you're not going to be able to make a sandwich. And as a result, how many sandwiches you're going to make, is now going to be based on that new number 10. So the actual number of sandwiches that get made here is only 10, not the 11 that we theoretically predicted on the previous slide. Okay? And so here's where our concept of percent yield comes in. The percent yield basically gives us our success rate for making these sandwiches. So we know that at the end of the day we were only able to make 10. In theory, we should have been able to make 11, right? If everything went perfectly well. And so if we set up a ratio of the actual number of sandwiches made over the total possible numbers, if we had 100% success, and multiply this ratio by 100, we get the definition for percent yield, which in this example would be 91%. Okay? So we refer to this actual number of products, actual amount of products that's being formed is the actual yield. And so our definition then as the actual yield is the amount of product that is actually produced by a chemical reaction, right? So think actually produced for the actual yield. Then the percent yield is defined as this ratio of actual over theoretical multiplied by 100. Now, in the context of a chemical reaction equation, there are many reasons as to why your actual yield will be less than your theoretical, right? You could, of course, drop some of your reactant molecules. You could spill it. Or some of those reactant molecules could be stuck to the side of your Erlenmeyer flask or beaker or wherever you're carrying out that reaction, right? There could be other side reactions that are occurring that are decreasing the amount of your desired product that are being formed. So there's a lot of different things that can go on here. Suffice it to say, you will always have an actual yield that is less than your theoretical. As a result, you will get a percent yield that will be something less than 100. So now with these definitions in mind, we can set up a method for determining percent yield. So as always, we're going to start off by converting the gram quantities into moles that are given to us in our reaction problem. And we're then going to use mole-to-mole conversions to figure out the moles of product, just as before. Then we're going to identify the reactant that makes the least amount of product, right? We need to find we still have a limiting reactant problem built in here. Then we're going to determine the amount of product that can be formed in theory by using up all of that limiting reactant, and that will of course give us our theoretical yield. And then finally, we are going to take the actual yield that will either be determined experimentally in the lab or given to you in the context of a problem, divide it by the theoretical yield that we just got in step 4, multiply by 100, and you've got your percent yield. Okay, so let's go ahead and look at an example. We can go back and look at our titanium dioxide reaction with carbon. And now let's suppose that we know both the amount of initial reactants that are given and the fact that at the end of the day, when this reaction is carried out, we know that 42.8 kilograms of titanium is actually produced. Okay? So we now have an actual yield. Okay? So we're going to proceed just as we did before, right? Carrying out those conversion factors outlined in the previous video. We can plug in the values. We will then, determine the limiting reactant, which is, once again, titanium dioxide. We'll determine the amount of product that reacting all that limiting reactant will produce. We will then multiply by the molar mass of titanium and ultimately switch it over to kilograms to figure out the theoretical yield of titanium. Okay, so a theoretical yield of titanium right down there. Then we are going to, again, go back to that problem and plug in to our percent yield calculation the actual yield from the problem and the theoretical yield from our previous step 4 to determine the percent yield for this reaction, which comes in right at 80.9%.